Okay, the first kind of stoichiometry, besides the simple mole to mole we did a few minutes ago, or just shortly before you start this section, is gravimetric stoichiometry. Now, think about G, gravimetric, is going to involve grams, GG grams. It's going to involve masses, essentially. Now, you have to understand way back when we started, in Chapter 8, when we started to talk about the mass of a mole of elephants and the mass of a mole of feathers. They clearly have different masses because each substance is different. So that being said, you cannot take a recipe for a balanced chemical equation, like we've just been doing, and convert from grams of one substance to grams of another substance directly because they don't have the same molar masses. So we cannot do this. That's a no-no. We can't do it. When you want to make a conversion, say you're given in that very first question, the very first page of Chapter 9, it said you had 725 grams of chromium 3 oxide. How much chromium could you get? You can't do it in one step. Everything has to go through the mole. Let's refresh. To go from grams of a substance into moles, you can do that very easily if you know the molar mass. I'm going to say use the molar mass of substance A. If you want to change from grams of A to moles of A, that's one step, and you're going to use the molar mass. Now, if you know the substance amount now in moles of anything in your reaction, you can convert that into moles of another substance in the reaction directly by using the mole ratio, which we determined comes from the balanced chemical equation. Now that's two steps. Notice two arrows. The first step, grams to moles, use the molar mass. The second step, from moles to moles, use the mole ratio. The third step, if that's required, it usually is, you want to change from moles of the new substance up to grams of the new substance. Therefore, you're going to have to use the molar mass of substance B. You're going to need a couple things before you start the question. You're going to need molar masses of each, and you're going to need a mole ratio, which means the equation is going to have to be balanced. 3 steps. Molar mass of B. Okay, you cannot change from grams of one substance to grams of another directly. You have to go through basically the mole hole. From grams to moles, from moles of one to moles of the other, and then back up to grams. So the first example in your booklet, example 3, is not quite that complicated. It's a building up kind of question. Example 3 says, how many grams of oxygen, below the O2 I'm going to put a G and a question mark, how many grams of oxygen are required to burn 3.48 moles of the ethane? So if you go back 1 second with me to the previous slide, we are given a starting amount in this question of the moles of A. We don't have to do this step. That was already done for us. We are going to start at the moles of A, we're going to convert to moles of B, and then we're going to change to grams of B. So it's not a complete 3-step question, but it's building up to that. So under each new question you have to say, what are my steps? The first step is always to write a balanced chemical equation. Well, all I have here is the skeleton. This is the same equation we worked on previously. You can pause it and balance it, or you can remember from yesterday, whenever we did this, do 746. So now, let's look at my plan. I'm starting at the moles of ethane. And I want to convert that to grams of, I cannot convert from moles of ethane to grams of oxygen. That's impossible. But I can convert from moles of ethane to moles of oxygen, and then I can go from moles of oxygen to grams of oxygen, because that has a molar mass. This is a two-step question, and I'm required to know before I start the molar mass of oxygen. And the molar mass of oxygen is going to be what you would expect. 16 times 2, 32 grams per mole. Now listen to the words coming out of my mouth. You never use the coefficients in the molar mass. The coefficients are only used for the mole ratio step. Okay, never use the coefficients in the molar mass. So now this is where you need to listen to the words and follow along with the units. I'm going to write down what I'm given on the far left. 3.48 moles of ethane. Okay, my recipe says 2 moles of ethane can produce 7 moles of oxygen. First of all, I have 3.8 moles of ethane. With that, I can find how many moles of oxygen that will be equivalent to by using the mole ratio, by using the stoichiometric coefficients. On the bottom, what I want to get rid of is moles of ethane. The number in front is 2. So 2 moles of ethane that came from the equation will make, or use up in this case, because it's a reactant, 7 moles of oxygen. And this step is the mole ratio. And the mole ratio comes from the coefficients in front of the balancing. If I stopped there and did the math, the moles of ethane would cancel. I would take 3.48, multiply it by 7, divide it by 2, and my answer would be in moles of oxygen. But I don't want the moles of oxygen, I want the grams of oxygen. So now I want to carry on and use my molar mass to convert to grams. What you want to put in the bottom is what you want to cancel. My molar mass says for every 1 mole of oxygen, there's 32 grams of O2. And this number is the molar mass. And that's the kind of work that you did in Chapter 8. Now, if I cancel the units now, my moles of oxygen would cancel, and I'd be left with grams of oxygen, which is what I want. Now, in terms of the calculator usage, pick it up, plug it in. You're going to get 3.48 times it by 7, divide it by 2, times it by 32, and then divide it by 1. So calculator-wise, you're going to get 389.76. That's the calculator answer. To finish it off, and to do significant digits, you're going to have to round to 2 places. Or sorry, 3 places, which means that 7 is going to round the 89 up to a 90. So 390 with a decimal point grams of oxygen, or 3.9 times 10 to the second. 3.90 by 10 to the second would be the equivalent. That is not a complete gravimetric. It's not a gram to gram question, but it is a almost gravimetric. The next page, example 4, is a good one. It says the explosion of nitroglycerin is described by the equation below. How many grams of carbon dioxide are produced by the explosion of 21 grams of nitroglycerin? So how many grams of carbon dioxide, put a G under front or below my CO2, are produced by the explosion of 21 grams of nitroglycerin. So there's obviously nitroglycerin. The only thing you don't recognize must be the nitroglycerin. And you should know that you cannot change from grams of one substance to grams of the next directly, because they don't have the same masses. So you can't do from one to the other. Everything has to go through the mole. So you start with a plan. You're going to change the grams of nitro to the moles of nitro. You can use the molar mass for that. Look that up. If I know the moles of nitro, I can look at my balanced chemical equation and I can say for every 4 moles of nitro, I'm going to get 12 moles of carbon dioxide. So you can definitely convert from moles of nitro to moles of CO2 if you use the mole ratio step, which is a 4:12 ratio. And then once you know the moles of carbon dioxide, you can change the grams of CO2 if you know the molar mass. And that's easy enough to find. So my recommendation is before you start the question, you go off to the side and you find all the required components. So you need to have the molar mass of CO2, 1 carbon and 2 oxygens. You can pause it, go off and figure it out, but it's 44.01 grams per mole. That's for CO2. Notice I'm putting that number directly beside the CO2 in the question. And to do nitroglycerin, you should pause it, do the nitro, and come back. Remember, you only use the chemical formula for molar mass. You never use the coefficient. So 3 carbons, 5 hydrogens, etc. Pause it here. Okay, so it's going to be 227.11 grams per mole for that chemical formula. It's a lot heavier because it's a lot bigger. Now all the intro work is done. Now you need to organize and you need to write the equation properly. So here we go. 21 grams of nitro. I'm going to write nitro instead of the whole chemical formula because it's too long and I don't have enough room. If I want to change from grams of nitro into moles of nitro, the molar mass states I need 227 grams for 1 mole. Top I'm going to put 1 mole of nitro. In the bottom I'm going to put 227.11 grams of nitro. If I stopped there and did the math, the grams of nitro would cancel. And my answer would be in moles of nitro. I would be right here. That's where I'm at right now. Moles of nitro. So I want to go onward, and I want to change from moles of nitro to moles of carbon dioxide. So this step that I just did was the molar mass of nitro. Now I'm going to convert from moles of nitro to moles of carbon dioxide. I'm going to do this step. Step 2. Each fraction in your conversions is an arrow on your diagram. So for every 12 moles of CO2, which is what I want to find, 4 moles of nitro on the bottom. And they will cancel. Moles of nitro, moles of nitro. And then the last step will be, and that's my next arrow done, so now I'm here. And now I have an answer in moles of carbon dioxide. I want to change it to grams. I already know my molar mass. So for every 1 mole on the bottom of CO2, you're going to use or make 44.01 grams of CO2. You check out the units will help you. So use the units, that's why they're there. Moles of CO2, moles of CO2. So the second step was the mole ratio. And the third step was the molar mass of CO2. So into your calculator, you're going to type all those numbers. 21.0 divided by 227.11 times it by 12 divided by 4 times it by 44.01 equals, you're going to get an answer. The answer in your calculator is going to be the unrounded 12.208, which is going to be 12.2 grams of CO2 when you're done. And that is a true gravimetric calculation because it changed from grams of one substance to grams of another, and it used the mole ratio in the middle step. So you used 2 molar masses, you used 1 mole ratio, and the equation was balanced to do so. This is stoichiometry. It's conversions, conversions, conversions. It's using a recipe to predict how much product you can make based on how much reactant that you have. So let's do the last one here on this page, example 5. This is an old classic. This is a classic because I've only given you the reactants. So I would like you to pause the video, go off and figure out the products, identify what kind of reaction it is, balance it, and don't forget the states. Because the question is going to ask you, as you can see, how many grams of precipitate will be formed when 24.9 grams of nickel 2 chloride react. So you need to pause the video and then come back. Okay, I'm going to finish the reaction. Double replacement, so the silver's going to go together with the chloride and the nickel's going to go to the nitrate. Silver's a 1 plus, chloride's a 1 minus, and the nickel nitrate, we know that nickel's a 2 plus, so it's going to be Ni bracket NO3 taken twice. And the states are really important. You should know that all nitrates are soluble. That one will be aqueous, and by default, the silver chloride will be the precipitate. If you go to your first column, the yellow table on the solubility table, it'll tell you that silver and chlorine are not soluble. That's going to be your precipitate. We want to know how many grams of that. We can make it in the lab. So we have a skeleton equation. It's not balanced. Your next step then will be to balance it. So chlorines on the left have 2. You need to put a 2 in front of the silver chloride and a 2 in front of the silver nitrate. There's your balanced equation. Now, we're given grams of a reactant. If we want to find grams of product, we can't do it directly. We've got to go through the mole. So grams of nickel chloride, nickel 2 chloride, change that to moles. I can convert from moles of nickel 2 chloride to moles of silver chloride, and then to grams. 3 arrows means 3 steps. You have to go off to this side before you start the question and find the molar mass of nickel 2 chloride and find the molar mass of silver chloride before you start the question. So nickel 2 chloride, 1 nickel, 2 chlorines, 35.45 times 2, plus your nickel, 129.59, and silver chloride, I think it's 107.87, and 35.45, it's 143.29 grams per mole. That's preliminary work. That's setup work. And now we do the question. So we have to write down what we're given. We have 24.9 grams of nickel 2 chloride. We want to change that into moles. To change from grams to moles, you divide by the molar mass. So 129.59 grams of nickel 2 chloride for every 1 mole of nickel 2 chloride. If you stopped there, your answer would be the moles of nickel 2, right here, the moles of nickel 2 chloride. Now the reaction says for every 1 mole of nickel 2 chloride, you're going to get 2 moles product. That becomes your mole ratio. You've got to organize that accordingly. What you want to put on the bottom is what you want to cancel, which is your nickel. So for every 1 mole of nickel 2 chloride, you're going to make 2 moles of silver chloride. And now you're here in your flow chart. You would now have an answer in moles of silver chloride. And your next step is going to be to figure out the grams. If you know your molar mass, that's easy. We've already found that out, so we know for every 1 mole of silver chloride, it has a mass of 143.29 grams of silver chloride. And then what we'll cancel now will be moles of silver chloride, and your answer is going to be grams. So on your calculator, it's a matter of plugging it all in. 24.9 divided by, because it's on the bottom, 129.59, times it by 2, divided by 1, times it by 143. You're going to get an answer, 55.06, and so on. That's the unrounded answer. And significant digits, 3 places, 55.1 grams of silver chloride. That's the amount of precipitate you can expect in the lab if you did the experiment. That is stoichiometry. Gravimetric, gram to gram. You cannot change from grams to grams directly. The number of steps of arrows in your plan will equal the number of conversion factors in your work below. That's it for now.